Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello, my name is Asante Jisa and I'm a biomedical engineer for the Oxygen Alliance, and I'm with my colleague
Ephraim Mandala, also a biomedical engineer for Oxygen Alliance. Today, we're going to tear down an Invacare Perfect Oxygen Concentrator. This oxygen concentrator operates on 120 volts AC with a tolerance of positive and negative 10% at 60 Hz. It delivers up to 95.6% oxygen concentration at flow rates ranging from 0.5 to 5 liters per minute.
In this video, Ephraim will take you through the external parts as well as the electrical system of the concentrator, and I'll take you through the internal components and the pneumatic system. So please stay with us.
Now, let us look at the external parts for this oxygen concentrator. Here we have circuit breaker reset button, power switch, humidifier bottle holder, hour meter, flow meter adjustment knob, oxygen outlet port, and finally the indicator lights panel. This panel consists of LEDs that indicates the status about the machine's performance and other issues. The first LED with the bell icon indicates the system failure and it lights red. It is normally accompanied by an audible alarm when oxygen purity is below 73%. The second LED with triangle and exclamation mark icon indicates low oxygen concentration. It lights yellow when the oxygen concentration is between 73% and 85%. When there is a sensor failure, the yellow indicator flashes. The last LED with the oxygen icon indicates that the system is working properly and that it's producing above 85% oxygen concentration. And this LED lights green. This icon signifies an audible alarm. At the back of this oxygen concentrator, we have the gross particle filter, auxiliary oxygen port, and a power port. For more details about these external parts, please find the link in the description below.
Now let us explore the internal parts of the Invacare Perfect Oxygen Concentrator and their functions.
So to access these internal components, we have to loosen 2 screws in front and the other 2 at the back.
To do this, we are going to use a star head screwdriver. We will start with the back side of the concentrator. So firstly, we have the compressor inlet filter. This filter removes contaminants from the air before it enters the compressor. And underneath here we have the intake muffler. This is used to reduce the compressor suction sound. These are the 2 sieve beds. These sieve beds contain a material known as zeolite, which absorbs nitrogen as air passes through them, thereby concentrating the oxygen. This is the pilot of a rated 4-way solenoid valve. This valve is responsible for the switching of airflow between the compressor, the sieve beds, as well as the exhaust. Connected to the solenoid valve is the exhaust muffler. This muffler is used to reduce the sound that is produced during the nitrogen purging. Now moving to the front, we have the concentrator's compressor. This compressor is of the Thomas brand 2660 series. It draws in ambient air and compresses it to a pressure of 21 psi before this air is delivered to the sieve beds. This compressor has two fans, one on this side and another one on the other end. And these fans are used to draw in ambient air and provide cooling to the compressor. The compressor has a voltage rating of 115 volts SC at a frequency of 60 Hz, and it also has a current rating of 3.8 amps. This is the pressure relief valve. This valve is fitted to the compressor and it pops out whenever the pressure exceeds the required pressure. And it is preset at 35 psi with a tolerance of plus or minus 3 psi. Right here we have a start capacitor. This is crucial to help the compressor motor to start up, and it is a 10 microfarad capacitor. Connected to the compressor here is a heat exchanger, and this heat exchanger is used to lower the temperature of the compressed air before it enters the solenoid valve. This is a transformer. This transformer steps down 120 volts SC to lower output voltages that are required by the electronic components on the board as well as the valves. This is the equalization valve. This valve allows part of the pressurized oxygen to enter the depressurized sieve bed. Here we have the outlet HEPA filter, also known as the bacterial filter. This filter is used to remove contaminants from the concentrated oxygen prior to delivery to the patient. On this side, we have the oxygen product tank, also known as the reservoir tank. This tank holds the concentrated oxygen before it is delivered to the patient. So to access the other components, I'm going to remove the upper cover. This cover is held in place by two screws, one on this side and another one on this side. So I will loosen the screws. Now I'll disconnect all the connections going to the upper cover. These include the tubings as well as the electric cables. This component here is the pressure regulator. It regulates the pressurized oxygen down to 5 psi. This is the cooling fan. It draws in ambient air which is used to cool the internal components of the unit. Right here we have this unit's printed circuit board. This board controls the switching of the solenoid valve and also the operation of all electrical and electronic components, including the fan, the oxygen sensor, the compressor, as well as the buzzer. It also controls the alarm systems, and it has the following crucial components. This is the pressure transducer, and it is used to monitor the pressure conditions in the product tank. This is the oxygen sensor. It is a ceramic zirconia sensor, and it monitors the oxygen levels that are produced by the concentrator. The oxygen produced by the concentrator flows out of the product tank and into the flow meter, but a small flow of this oxygen is sent through a precision orifice to the oxygen sensor. Please find the technical overview of this sensor in the description below. The printed circuit board also has 3 connection pins. This one is for the DC output, this one is for the transformer input and output, and this one is for the AC input and output. Right here we have the buzzer. So this buzzer produces a sound designed to alert the user of any potential problems or deviations from the normal operating conditions.
Now I'll take you through the electrical system for this oxygen concentrator. As mentioned earlier on, this oxygen concentrator operates on 120 volts AC. This 120 volts AC is supplied to the unit by the power cord. This power cord has 2 cables, brown live, while the blue cable is the neutral. So this is the neutral cable I was talking about. The neutral cable is connected directly onto the neutral AC input pin on the control board. The live cable is connected on the circuit breaker. That trips if the cable carries a current exceeding 3 amps. From the circuit breaker, the power is tapped to the power switch using this cable. Now, from the power switch, the live cable supplies the control board with 120 volts AC through this AC input pin. Now from the AC output pins, the cooling fan is supplied with 120 volts AC through this live cable, with the blue one being neutral to the fan. This 120 volts AC is also supplied to the hour meter through this live cable, with this blue one being the neutral to the hour meter. The input side of the transformer is also supplied with 120 volts AC through this live cable, with this blue cable being the neutral. The transformer is a mat voltage type with 3 output terminals on the secondary side. The yellow cables provide 20 volts AC and the orange cable provides 10 volts AC. These low AC voltages are fed back onto the control board, where they are converted to DC voltages needed to power the components like 3 indicator lights, buzzer, pilot operated 4-way solenoid valve, and the equalization valve. These orange cables from the board power the 4-way solenoid valve with 24 volts DC. These are the cables that brings power to the pilot operated 4-way solenoid valve. The yellow cables power the pressure equalization valve with 24 volts DC. These black and red cables power the buzzer with 12 volts DC. And lastly, the white cables power the switch with 12 volts DC. Note that the activation of valves and buzzer is determined by the microprocessor. This microprocessor uses the system conditions and timing sequences to turn the components on and off once the power is supplied. The compressor is also connected in parallel with the power cables, hence it also receives 120 volts AC, with this brown being live and this blue being neutral. These are the cables that power the compressor. A starter capacitor is connected in series with compressor's stator winding. That's all on the electrical system of this oxygen concentrator.
I'll now take you through the pneumatic system of the Invacare Perfect Oxygen Concentrator. Firstly, ambient air is put into the machine and it passes through two filters, the cabinet filter and the compressor inlet filter. These filters remove dust and contaminants. The filtered air then enters the compressor through the intake hose. This is where the air is pressurized to a pressure of 21 psi. This compression increases the air temperature, and this is where the heat exchanger comes in order to cool the air before it continues through the system. Now the cooled and pressurized air moves to the four-way solenoid valve through this inlet hose. The valve then directs this air to the two sieve beds. In the sieve beds, nitrogen is absorbed while oxygen passes through to the product tank. At the same time, a small amount of pure oxygen is sent to the top of the second sieve bed through the pressure equalization valve. This flushes out the leftover nitrogen and partially fills the bed with oxygen to prepare it for the next cycle. Starting the cycle at a higher pressure improves efficiency as the compressor requires less time and effort to reach the desired pressure for absorption. Once the oxygen has been separated, it flows from either of the two sieve beds through these two tubings while passing through these one-way valves, and finally moves to the product tank. From there, the air is regulated to a pressure of 5 psi. It then proceeds through this tubing to the flow meter, the outlet HEPA filter, and then finally passing through this check valve before it is delivered to the patient. The tube going to the flow meter is connected to this port. The tube going to the transducer is connected to this port. And finally, the tube going to the oxygen sensor is connected to this port. The nitrogen that was separated out is released back into the room air through the four-way solenoid valve and the exhaust system. A muffler is located at the exhaust end of the valve to reduce the sound of the exhaust as it exits the concentrator. And that concludes the pneumatic system of this oxygen concentrator.
Now I'll show you how to remove the compressor. Before I remove the compressor, I have to completely remove the upper cover, the sieve base, the cover on top of compressor, and the one at the back. Now, I'm going to remove these sieve beds. To do this, I'm going to use the cutter to remove the cable tie. The sellotape to seal the openings from the sieve beds. Now I'm going to remove the helper filter and intake muffler holder, which is held in place by 3 screws, 2 on the top and 1 at the bottom. Lastly, I'm going to loosen the 3 screws holding the back cover in place. To do that, I'm going to use star head screwdriver, Torx driver, and T20. Now I'm going to disconnect the holder from the intake hose of the compressor. Then now to remove this back cover, I have to loosen the hose clip. So I'm going to use the flat screwdriver. Now I'm going to disconnect the cables supplying power to the compressor. This compressor is held in place by 4 bolts, 2 on this side and 2 on the other side. To loosen these 4 bolts, I'm going to use spanner number 16. Now you can easily remove the compressor. If you want to remove the compressor completely, you can cut the cable ties. Now we're going to reassemble the internal components for this oxygen concentrator.
That's all we had for you today. Thank you for watching this video. Don't forget to like, share, and subscribe to our YouTube channel.
Bye.
Bye.